Hello guys, my name is Tadeu Barbosa and today I would like to talk to you about machine learning and specific machine learning implemented in Java, okay? Here, now I will show you three basic algorithms: classification, regression and cluster, and see this how to implement these three kind of algorithms in Java. So let's get started. Started by clustering. So the main idea behind of clustering algorithm is to grouping similar instances into clustering according to the same distance measure. Okay, the main idea is to put instances that are similar into the same cluster. Here we have two examples about this algorithm. The most common form about cluster is the instance plot, like a ball or a sphere, but nothing wrong with this example. It's a more disformal example, but it's okay. The instances are grouped. You can see the group. So in theory, this instance, these points are in the same group, should have similar properties or features, okay? So it's a very useful algorithm to understand better the behavior of your customer, of your services, or to make upsell, cross-sell in your business, okay? Clustering is an algorithm of unsupervised learning method, okay? And the most common algorithm is K-mean algorithm, okay? So let's to move on about next topic: supervised learning. About supervised learning, we have two algorithms: classification and regression in our example. The key concept behind the supervised learning has a learning examples. So here we call D about learning examples. These learning examples has features, and the goal of supervised learning is to find the function that predicts a target variable, okay? So this is our model. With supervised learning, you can do amazing things like voice recognition, email filter spam, detecting credit card frauds, affinity. You can have a lot of business real situation that you can use in your business, okay? The first algorithms, classification. Classifications is very useful, and it's normal used when you have to predict one of the mutual exclusive value in the target variable, okay? So think of classification like a discrete class, or you have a yes or no answer, or today is it raining or not. I need to approve the credit of my customer, yes or no, okay? So the classification has these characteristics. We need to put our prediction in one and mutually exclusive one variable. Some popular algorithms includes decision tree, Navy Bayes classifier, neural network, and Ansible methods. Here in our example, I will show you decision tree. Decision tree is a more visible and better to understand what really do in the algorithm. It's very clear to understand how decision tree works, okay? So in specific in a decision tree, where each node corresponds to one of the attributes that we have. The edges correspond to possible values of these attributes, and the leaf corresponds to a class label, is okay? the decision tree can be used to visualize and as I said, explicitly represent the prediction model. It's very useful algorithms. One important thing about classification is how can I evaluate my model. This model is good or not. So, okay, what is model if you try different approaches, different classification algorithms, what is the better? So, okay, so it's very important you have metrics to evaluating your classification. In specific classification, we count how many times we classify something right or wrong. Okay, and suppose that you have two options. I needed to give a customer credit, yes or no. So our label here is yes or no. So we have four options. We have yes or no, okay, and we have true positive, okay. So I gave the credit and this is okay, and I gave the credit but I didn't. I really didn't. So we have true positive, true negative, false negative, and true negative. So how can I do a metric about classification errors? We can count the total errors divided by the total of the numbers that we have, counting true positive and false positive and false negative, okay? And with this metric we can know about the classification error, and the classification accuracy is the one minus the error, okay? So we can count about not the errors but the correct counts that the algorithms did, okay? So it's very important to evaluating our classification and to see if the model is it is a good fit to our necessity. And the last, regressions. So here we have four instances about regressions. Regressions, instead of classification, deals with continuous target. So you have a process that estimates the relationship among features. That is how each feature is varying and changes the target variable, okay? As classification, we have some ways to evaluating our regression, and it is important. The more common is correlation coefficients. It's very useful to evaluating our regressions. And here in this four examples, we have in the left side two models that it's better to understand as a regression model, okay? In this specific, we have an outlier here that we need to understand a little bit more in details this data, but it's okay, the model it's okay. And in the right side we have models that not good fit to regression, okay? The distribution are not so good. And it might be you are asking why implement machine learning in Java. It's very common. You see implementations in Python, in R, in other languages, but Java is because first of all I love Java, so it's my preferable language, and Java is a very useful and very common language to implement backend services. And integrating these backend services with machine learning can be easy and bring good results to your project. So here we have some implementations, platforms, frameworks that you can use to implement machine learning in Java. Here we will use Weka to implement our examples, but we have others frameworks and libraries, Apache Mahout, Spark, very useful, very powerful, and other more specific like deep learning for J, when you has problems to understand and recognize images. So we have a lot of options to implement machine learning in Java. Okay, so let's go to the code. Let's move to the Eclipse. In the YouTube description, I will put the URL about the Git, where you can download this example and this project. The project is very simple, is a Maven project. So here is our Pom XML. The main dependency is the Weka dependency. Okay, so let's start with the classification demonstration. Here what we have, well, first of all, we have 3 data sources that we use in this project. One of the bank and the zoo and the others to make the cluster. So here in the classification we use the zoo. Okay, here is our data set. About the data set, we can see that we have some attributes that describe what an animal is. Okay, so we have if the animal is a milker, if animal put eggs, if how many legs the animal has, and so on. And here we have our description about the attributes, and here we have our data. So we have in the first column the animal, and the others the information about the attributes. Okay, so we have almost 100 animals in this data set. Okay, our goal is to predict an animal. So if you give to the algorithms these attributes, which animals they will answer to us. Okay, what animals we are trying to represent. So let's get started with the classification. Here we have a main method in Java. Okay, I don't need to explain about this. In our constructor we load the data set. Okay, and here we use the data source class to do this. We pass the string where our path about our file, so how the data set is our class path. So I needed to put only the zoo R. We have a data source class and we receive a path. We use this path to instance a data source, and here we can see the number of instances that we loaded. Okay, and if we use the toString method with our data source, it will show you our data set. Okay, so let's get started with this first. Let's comment and run. Okay, so here we have 101 instances loaded, it's correct, and here is the result of the toString method. It's nothing more than the dataset itself. So here we have the attributes, and after the attributes we have all the data. Okay, perfect. So if you see in this attribute instance, we have the first attribute, we have all the animals names, all the animals labels. Okay, so in our examples we don't need to use this attribute, so we need to remove these attributes about our dataset. So it is what this remove first attribute method do. So we need to remove the first attributes. Okay, so we instance an array of strings and set these options about our data. And let's move this to this to see that our, okay, run again, and of course remove the first attribute is uncomment. And as you can see, we don't have the label animals. So what we have in the attributes is only the attributes that we are using. Perfect. And other useful methods that I implemented is what these features is the better features that describe our classification. Okay, because I can have 10, 12, 13, 14 attributes about my dataset, and we have 3 or 4 attributes that is the most important features that I need to understand and I need to explain. So it's very important to know, for instance, here is this output, which is the best attributes that we have in this model, which is the best attributes that describe this model. So in order, the 11, 12 is the better attribute that describe it, followed by the 3, 7, 2, and 4. So here is a useful way to see how attributes works, how is this the best attributes. Other useful methods, building a classifier. So here we use a class J148 to build our decision tree, and as you can see here, I can string this output and see how the decision tree works, the number of leaves that the decision tree has, and the size of decision tree. But it's not so visually to understand the decision tree in this way. I prefer to see using this method that we can use a tree visualizer, and you can see the property, you can see the edges with the values, you can see the label bird. So this way is how the decision tree works. The first attributes that the decision tree will see is a feather. If true, then it classifies as a bird, and you have 20 animals in our 101 that is bird animals. And if feather is false, then we go to another attribute. It's milk. Oh, okay, milk is true. Oh, so the label is mammal, and we have 41 attributes in our dataset. So we have, if you count our labels, 1, 2, 3, 4, 5, 6, 7, 8, 9 is this number of leaves. We have 9 labels. So we can understand better and visualize what a decision tree really do. But my friends, what's the main goal of the classification is this: classify data. We have a data set that we trained, we build a decision tree, but I have an attributes about an animal, and I would like to know what animal is this. Okay, it's all about our classification. So in this way, we have tried to put some attributes that represent like a unicorn. So here we have the great answer about the classified data, and here we have what's the animal it's a unicorn is. Then our algorithm classify a unicorn like a mammal animal. Okay, well, I think that it's correct. And finally is about metrics and evaluation. Okay, so it's very important to understand how is it good our model, our data set. So here I implemented this classifier and this evaluation to see this guy. So we need to comment the visualizer tree and run again. So here we have some useful information about the metrics. So here we have the correct classifying instance. It's very important number, so our number is very higher. Okay, it's a good data set and it's a good model to us. We have root mean score rate, we have total relative score squared error, total number of instances. Okay, and here in this confusion matrix we have, for instance, in label A, 41 animals that we classified as mammals. Okay, we have 20 animals that we classified as bird. We have 3 animals that is reptile, but we have 1 animal that we classified as fish and 1 animal that we classified like an insect. If you can see above, we have 8 incorrectly classified answers. If you count 1, 2, 3, 6, and 8, okay, if you have all the classified instances correctly, we have in this way. Okay, but here we have at the same line others classifications. What it is important? It is important to better understand our data set, if you see if the data is correct or not. So you need to see in more details about this kind of data. Okay guys, so here we have a lot of information about this basic algorithm. We load our data, we remove attributes, we show how features are better to and better represents our model. We built the decision tree, we classify new data, and you can see metrics and evaluation about your model. Okay, so this is our classification example. Let's go to the regression, linear regression. It's the same way that we have, we need to import and load the data. Okay, here we do it in the same way, a little bit different because this file is a CSV file, so we use a CSV loader instead of data source. And here let's to run this import. Okay, so here we have our data set. The data set is a little bit more bigger than the classification. We have the attributes and we have our data. This data set is about the heating and the cooling in some buildings, and efficiency about heating and cooling in some buildings. So we have 80 attributes that describe the building and about the heating and load. You can see more details in the data. Okay, so here we have the information about our data set. So let's to build our linear regression and comment this method. But first, it's important to understand that in this build linear regression method, I remove the last information about the cooling. So we will study this model, this data set about the heating perspective only. Okay, so if we run, let's comment here and then comment here, run as Java application. Yes, this is the most important. Okay, here we have our linear regression model. So we have a function that describe our attributes. So If you have this information, we can outcome the heating load. Okay, so the objective of the linear regression is to find the function that defines the relationship between the attributes and the heating load in this case. And of course we have an evaluation model to see information about the total instances that we have, root mean squared error, correlation coefficient, so it's important that this number is positive to see that the attributes has a relationship between them, and other information about a metric, so you can test, you can see, you can verify your model and your linear regression model. Okay, and the list is about our simple example about the clustering. So here we load the file. Our file is a bank, and this we use the EM model class in the Weka to build our cluster. So let's just see, open. Okay, this is our data set, and you have some information about your customers. Okay, you have some attributes like age, sex, region, married, yes or no, children, yes or no, cars, and so on. So the goal of this algorithm is to clustering these customers in grouping this kind of clusters. So let's to run this example. The cluster algorithm, it's more, well, let's to comment the evaluation model, because the evaluation model, it's a slow method. Building our cluster, 3, 2, 1, our cluster. Okay, so here we have our cluster. If you can see, you have they determined 6 clusters. Okay, and here we put the attributes and the distribution that they found. Okay, so here we can interpret and see what the algorithm really do. So we have all the attributes and the clusters that the algorithms found. Perfect. If you run this evaluation model, this is a method very slow, so you can do by yourself in your home to see some informations about the clustering model. Okay, so guys, back to the presentation, and today is it. Thank you a lot to visit us and to watch our video. I hope you like it, and if you can and you like to follow me on LinkedIn, here is my profile. I really appreciate, and we can talk about machine learning, Java, and other things. And our website is this, cbds.com.br, and follow us on the YouTube. And next couple weeks we will record other videos with machine learning and Java. Okay, thank you a lot, and bye bye.